We just built our most powerful system yet with 96 CPU cores and half a terabyte of RAM. But why? Before we go into any details on the specs, it's important to contextualize the numbers. So basically we have two models of workstation. We have the Vulcan and we have the Hydra. Now our Vulcan is our standard for high-performance computers, and while there's no truly one-size-fits-all solution, this computer can be spec'd to cover 99% of professional workflows. For example, if you're going to be doing CAD work and 3D modeling, we might want to spec something like an Intel Core Ultra 7 270K+. If you're going to be working with architectural visualization, we can spec something like an RTX 5090 GPU. And for large photogrammetry datasets, we can spec up to 192 gigabytes of RAM. In very rare cases, such as for high-resolution video production, we may want to step up to our Hydra line, which supports AMD Threadripper CPUs, such as the 32-core 9970X. Beyond this, it can be difficult to justify any more power because once you have a certain amount of CPU cores and a certain amount of RAM, the excess just simply does not get accessed. You'll know when you need more, and we needed more. So what would a system like this even be used for? For us, it is reality capture. So reality capture is a process of digitally recording real-world objects and environments. The goal is to create a unified 3D model that can be used for BIM workflows, digital twins, or any of a number of other use cases. There are a few different ways of capturing this data, but we use laser scanners. So a laser scanner is a machine that uses LiDAR that basically fires a beam at a nearby object, calculates the time it takes to return, and from that it can judge the distance. It continually moves and scans millions or even billions of times to get a complete picture of its surroundings. The result is what is called a point cloud. So when you're scanning a large building, you don't just scan once, you have to take hundreds or even thousands of overlapping scans throughout the building. Each scan must then be accurately aligned with every other scan. This alignment process is what is called point cloud registration. Once registration is complete, the unified point cloud can then be imported into Revit where BIM models are created. So why do we need a Threadripper Pro? Point cloud registration is a mathematically complex process, and it benefits enormously from high CPU core counts, high memory capacity, high memory bandwidth, and lots of fast storage. A few years ago, we built a high-end Vulcan for this purpose, and it was absolutely maxed out. It had an Intel i9 14900KS, it had 192 gigs of RAM, and it had an RTX 4090. So that Vulcan was already an extremely powerful machine, but even that wasn't enough for us. Our largest datasets were approaching 1.3 terabytes in size, and we started seeing projects that required over 300 gigabytes of RAM. This is where the Hydra comes in. To go into full details on the spec, this system has the most powerful desktop CPU available right now, the AMD Threadripper Pro 9995WX. The CPU has 96 cores and 192 threads. And as you can see, it completely blows the 4900KS out of the water. It has 512 gigabytes of ECC registered DDR5 RAM, and this RAM is running an 8-channel. It also has 10 terabytes of PCIe 5.0 storage, and an RTX 4080 Super for good measure. With the RAM running an 8-channel, the memory bandwidth is 4 times higher than our Vulcan. Our Vulcan has memory running in dual channel, which has a memory bandwidth of 90 gigabytes per second, give or take. With the Hydra running in 8-channel, that bandwidth goes up to 400 gigabytes per second. It's important to note that all the storage in this system is PCIe 5.0. For context, the Vulcan had PCIe 4.0 storage with a max speed of 7,000 megabytes per second. PCIe 5.0 storage, on the other hand, goes up to 14,000. So overall, this is the most powerful PC that we could have put together for reality capture. Now, reality capture isn't the only use case for a Hydra with the Threadripper Pro. There are a few other niche use cases. For example, 8K multi-camera video processing, engineering simulations like finite element analysis and computational fluid dynamics, and AI and machine learning workloads. Whether you need something like a Vulcan or a Hydra, please don't hesitate to contact us and we will be more than happy to put together a spec for you. Thank you.